Hello, I am David W. Parker. This is Programming Today I Learned, 3D Math Series, episode 32. This is part 6 in the Quaternion episodes, and we'll be looking at exponentiation. Exponentiation. This is a nice, short, sweet episode. So, what's exponentiation? It's raising something to some power of t. So in our instance, we'll have q to some t. Not to be confused with the exponential function from the last episode. So recall that when we have a scalar and we raise it to 0, it is 1, and if we raise that scalar to 1, it is always that scalar, where it is non-zero. So that looks like this, where you have 0 to t to 1 is going to end up being 1 to a to the t to a. Similarly, with quaternions, 0 to t to 1 is going to end up being within the identity of 1 and then 0 vector here to the qt to q. So what happens if it's greater than 1? Well, it's we still have a mostly same. So it's giving us, this is giving us fraction of the displacement, and this is going to give us like q to the squared is going to give us twice the angular displacement of q. And I say mostly here because we always used the shortest arc. So there aren't multiple spins. So if we take, for example, q is 30 degrees clockwise, and we take that to the fourth, it's not going to be 240 degrees clockwise. It's going to be 80 degrees counterclockwise, because rotating 240 degrees clockwise is the same as rotating 80 degrees counterclockwise. So you have to think about what is the shortest arc. And to this fact, some things aren't trivial. So for example, q to the fourth to the 1/2 is not equal to q squared. So the formal definition, though, is for this is qt is equal to the exponential times t log of q, and both the exponential and the logs are in the previous episodes, so if you need to look back and review, go ahead and do so. That's it for this episode. If you like what you saw, go ahead and subscribe and give a like, share on social media if you will, go to ProgrammingTIL.com and sign up for my newsletter. Have a great one. Thanks.